In this video, we're going to see how to do linear regressions using Desmos rather than the nSpire calculator. So for figuring out how to do regressions, linear, quadratic, or exponential on the handheld, on the calculator, there's a separate video on that. I'll try to put it in the description of this one. But this is the one from that video that I did the regression for. So we're doing a linear regression. Our data is here relating time and height. Those are our x and y variables. And we get our slope and y-intercept, and we get a correlation coefficient. So we're going to see how to do this same process using Desmos because that's a different tool available to us, and you have it available anytime at home or on your phone, so you don't have to have one of these calculators in order to do these problems. So to create it, first we're going to need a table like we have over here. To create a table, we don't just type, we have to hit this plus button for add item, and then we're going to pick table. It creates a table with the variables named x1 and y1. I believe we can rename those to be time and height, but I'm just going to leave them as x1 and y1 because I'm lazy and it makes sense to me. So I can type in a table just like I had on the calculator and put a 1 for x, and then my y value that corresponded was an 8. Once I do that, it's going to start creating a scatter plot. So I have a dot at 1, 8, and this looks kind of like a discrete function because it has just dots. So on my next line of my table, I'm going to put 2 and 14.4. That dot is up here because I need to zoom out a bit. So we have our 2 dots, and then we continue on typing our data. 3 and 28.8, 4, 57.6, 5, 128, scroll down over here, 6, 281.6, 7, 563.2, and 8, 921.6. So these are now far beyond the scope of what I've zoomed to, and it doesn't matter. I can zoom out or not, but just like over here, I don't have a graph at this point. I still get all the information I need. So I'm going to zoom out on the graph, but that's not a necessary step. It's just so that we can see where those dots are, because 921 is very far up on the y-axis. So it looks something like that. So now we're going to do a linear regression, which we need to type in an equation. So we're going down to this 2 box. If you don't have one, you can hit plus and hit expression, and that'll create another box for an expression. So the way we're going to do this is very different than the calculator. That's why we just kind of focus on one or the other usually. But if you follow along, you should be able to do this. We know that our equation we want is in the form y equals mx plus b. Unfortunately, it doesn't know what these things are. Desmos is like, I don't know what these are. What it does know is we've defined something called x1 and y1. So we're going to say y1 and x1 in place of y and x. Now, the problem is we've put an equal sign. So the equal sign doesn't work here because this is an approximation. Whenever we do a regression or any kind of statistical analysis like this, we're getting an approximate line of best fit. We're not getting an exact relationship because this is scattered data from real world data probably. So we're going to make one other change. We're going to change this equal sign to an approximate sign. We do that with the tilde character. So shift and the little thing next to the 1 on a normal keyboard, or if you're working on a mobile device, you'll have to find this tilde symbol that means approximately. So now we've written y1 is approximately m times x1 plus b. And what Desmos is going to do is figure out the best values for m and b to make that work. So m, the slope, it said is 118.667. And if we look over at the calculator, our slope was also 118.667. The y-intercept is approximately negative 283.6, exactly the same as it was on the calculator. So we get the exact same information. We also get r squared and r. So we get all the same data here that we got here. It's just a different process of how to type it in. So I'm going to go back one more time and just make a new expression. And this time I'm going to type it correctly from the beginning instead of replacing things. So what we want is y1 is approximately, so we're going to make that tilde character, our slope times x1 plus a y-intercept. So that's how we type it in, and that's how you're going to type it in every single time as long as you're doing linear. If you're doing like exponential or quadratic, then the form of the equation is different. So let me pause real quick. Okay, so I've modified the calculator now to be doing an exponential regression. So I took away the linear regression and changed it to do exponential. So the difference was we did menu 41, I forget, 41A. So we're doing this one instead of this one now, which again is outlined in that other video. So I'm not going to talk about that here. But we end up with a times b to the x, and we get these a and b values. So I want to look at how we could do that in Desmos. And you can probably make a pretty good guess is we're going to make that same kind of generic equation, a times b to the x, but we're going to put in the kind of notation that we did before and put y1 is approximately a times b raised to the x1 power. So when we do that, we get a is 7.4 and b is 1.8. Over here we have a is 3.7 and b is 2.0, so those are very different numbers. So if you want to get the same results that we have with the calculator, you have to click this little checkbox that says log mode. So for an exponential regression, there's this extra step where you have to click this button, and now we get our r values. So notice that we only had r squared, we didn't have r before. And now we have a and b that match exactly what we have in the calculator. So this log mode is a different method of calculating in the statistics of it all that is the method used by the calculator. So we need to make sure that if we use Desmos for exponential, we click that button. I'm going to pause one more time and change this to be a quadratic regression and look at how that works. Okay, so we've got this modified now to be a quadratic regression. Quadratics come in the form ax squared plus bx plus c, as it shows right here in the little pop-up. So what we're looking for are the variables a, b, and c to come out of our regression. So again, same exact process. We're going to do y1 is about, and we're going to put ax squared plus bx, whoops, I need to put x1, ax1 squared plus bx1 plus c, and I get, notice there's no log button, so I just get the same values. 31.1 is a, negative 161 is b, 182 or 183 if we round is c, and then r squared is 0.9855. So we're getting the exact same values from the calculator. We just have to make sure we know the format of how to type this in if we want to do it in Desmos. So hopefully that helps if you're working on these problems at home or on the Desmos Graphing Calculator app. This is a good way to do these problems without needing the graphing calculator.